The fundamental counting principle is if there are A ways of one activity to occur and B ways for the second activity to occur, then there are A times B ways for the both to occur. So here we have an example, and I'm sure you probably have seen something like this similar, maybe back in middle school. Andy has asked his girlfriend to make all the decisions for the date for her birthday. She will pick a restaurant and an activity for the date. Andy will choose a gift for her. The local restaurants include Mexican, Chinese, seafood, and Italian. The activities she can choose from are putt-putt, bowling, and movies. And Andy will either buy her candy or flowers. How many outcomes are there for these three decisions? So here I've made a tree diagram, and this is probably what you remember back from middle school. So we have our different restaurants, and then from the restaurants you can either go to putt-putt, bowling, or movies from each of those. And then after that you have the choice of candy or flowers. So the way that you figure this out is you just figure out how many end ways there are. So if I were to count all of the candy and flowers down here, you would end up with 24 different choices. Now the fundamental counting principle, which is also called the multiplication counting principle in some places, so if you see that coming up, that's also that. You would just simply multiply the different choices together. So you have 4 different choices for restaurants, and you have 3 different choices for activities, and he has 2 different choices for the gift. So if you multiply 4 times 3 times 2, you get 24. So that's just the shorthand way of doing the fundamental counting principle. Would be to do what we did over here versus the longer way, which would be to make a tree diagram. Number 3 says determine how many different computer passwords are possible if digits and letters cannot be repeated. Given that the password must have 4 digits, the digits are 0 to 9, so that's 10 different options, followed by 2 letters. I find it easier to start by drawing my lines that I need. So our passwords are going to be 4 digits. So I'm going to draw 4 lines, and I'm going to put a D for digit underneath of them, followed by 2 letters, and I'm going to put an L underneath those to represent my letters. Now I'm going to figure out how many choices I have for my digits in this first one. Well, I can have any digits from 0 to 9, so that's 10 different choices. Now we have a little bit of a problem with the second one because in the directions it says letters, digits and letters cannot be repeated. So we no longer have 10 options for this second digit. We now have only 9. And then we only have 8 for the third digit and 7 for the fourth digit. And then for the letters, there are 26 letters in the alphabet to choose from. Again, we can't repeat it, so we're going to write 25. And then you just simply multiply those together. So in your calculator, when you multiply them, you get 3,276,000. So those are the different passwords you have if letters and digits cannot be repeated. For part B, or number 4, PA license plates have 3 letters followed by 4 numbers if the same letter or number can be repeated, how many can be made? So this one's a little bit different because we are allowed repetition. So for the first option, for the letter, we have 26 options. We again have 26 for the second letter because we can repeat them. 26 for the third, and then the digits again we have 10. Now you could type that in your calculator the way it is, or you can do 26 cubed times 10 to the 4th. Just a little bit of a shortcut. So for your final answer, you get 175,760,000. The factorial symbol is denoted with what looks to be an exclamation point, but it is actually read n factorial, is the product of all positive integers less than or equal to n. So it's probably just easier to go ahead and start with an example. So in number 1 here we see 5 factorial. So 5 factorial means that your n value is going to be 5. So we're going to start with 5, and you multiply it by integers less than that till you get to 1, because you only want positive integers. So we're going to do 5 times 4 times 3 times 2 times 1. You multiply all those together and you end up with 120. For number 2, 0 factorial, I guess now would be probably a good time to show you where you can find factorial. So in a graphing calculator, you're going to go to Math, and then you're going to choose the option for PRB for probability, which is all the way to the right, so you can either arrow over to the right, I think it's 4 times, or if you just arrow to the left once after you hit the math, then you should see probability. And then the factorial symbol is number 4. So if you type in 0 factorial, you actually only get the number 1. 13 factorial would be 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6, 5, 4, 3, 2, 1. Or you can just simply type in 13 factorial into your calculator and you get a very large number. So we get billions. Probably takes longer to write the number than it is to actually type it in the calculator. For number 4, it's a little bit different because we can't type this in the calculator. So for number 4, n minus 2 factorial means that you're going to start with n minus 2, and you're going to multiply that by 1 less than that. So when you take 1 less than that, you end up with n minus 3. And then I'll subtract another one. So if you had n minus 3 minus 1, you end up with n minus 4. And then the next one would be n minus 5, and so forth. So that will go infinitely. So we put the dot, dot, dot to indicate that it will continue in that pattern. For number 5, in the numerator, you have n times n minus 1 times n minus 2, dot, 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 which means, let's just say this would be n minus 3 here, and then n minus 4, and so forth. And then in the denominator, n minus 2 times n minus 3 times n minus 4, and that will go on forever. So it's pretty safe to say that the n minus 2 here cancels out with that factor that's in the numerator. N minus 3 will cancel out with the n minus 3. The n minus 4, if you were to continue, would cancel out. So everything would cancel out in this one except for n times n minus 1. So that would be your answer. This little chart will kind of summarize the difference between permutations and combinations. So in the next lesson, we're going to be talking about permutations, and the major point that you want to take out of this one is that order is important when you talk about permutations. So when you order something, so if you had the letters C-A-T, that spelled cat, and you change the order of those letters, you would form a different word. So therefore, the order that the letters are written is important. So that would be a permutation. Versus a combination. And combination means that order is not important. So you can arrange something and it would be completely the same arrangement. So for example, a lot of times cards would be considered a combination, because if you had 5 cards in your hand, it wouldn't matter the order that you put them in your hand, you still have those cards in your hand. So if you had a 5 of diamonds, it doesn't matter if it's on the far left or the far right of your hand. You still have a 5 of diamonds. So that's kind of the major difference between permutations and combinations. We are going to focus on permutations coming up. So here we have this formula, and it's written in both ways. Again, it is found on your formula sheet. It is also found in your calculator, so you can use either of those. Your special case with repetition, so we're going to discuss that. And here you have some things to look for, some keywords. When you're arranging people, that definitely matters. So if you had Sue on one side and Bobby on the other side, if you arrange them like a seating chart, it would be a different seating chart. So it matters which order you put them in. Alphabets, letters, numbers. So if you had 1, 2, 3, 4, that's different than 4, 3, 2, 1. So the order that you arrange them is important. And then you have orders not important. So if you're picking from a menu, clothes, doesn't matter, you're still going to put the clothes on. And then again, sometimes you can use the fundamental counting principle to use with both of them. So we're going to do permutations next. For number 1, how many permutations are possible with the letters A, B, C, and D? So we have 4 letters, so I'm going to draw 4 lines. And it does matter the order because you arranging them, they are letters, they would be different arrangements. So for this first letter right here, if I want to arrange it, you have 4 different options. You can either put an A, a B, a C, or a D here. So you have 4 different choices. Now, unfortunately, because we only have one of each of them, you now only have 3 options for the second letter, and then 2, and then 1, which is just simply 4 factorial, which will be 24 different permutations. So they different arrangements of those 4 letters. Now for the next one, the starters for a 6-woman volleyball team have been listed in particular order, 1 through 6. If there are 13 women on the team, how many possible starting lineups are there? Well, you have 2 options, and I'm going to show you both ways. I'm going to show you how to use the fundamental counting principle to do it one way, and I'm going to show you how to use the formula for the other way. So the first way is you have 6 different starters. So I'm going to draw 6 lines for your 6 starters. Now for this first person in the lineup, you have 13 women to choose from. So I'm going to put a 13 there. And now for the second starter, you no longer have 13 women because you already chose one. You now have 12 choices. And then 11 and 10 and 9 and 8. Now this one's not a factorial because it does not go all the way down to 1. So you will have to multiply this out in your calculator, and you get 1,235,520. Now to use the formula, again, this is a permutation because we're dealing with people, so order is important. So I'm going to use 13 as your n value, so remember your formula looks like this at the top. I'll highlight it. So your n is how many you have to choose from, how many different people or objects you have to choose from, and you're choosing them R at a time. So R is how many you're actually taking from the bigger group. So n is 13, and then we're using a permutation, and then how many we're choosing is my R value, and we are choosing 6 women from the team. So let me finish writing that formula up at the top for you. It's n factorial, so this is just from the other page, and then in the denominator 13, oops, gotta write it in general, n minus r factorial. So that would be the overall the formula. So I'm going to go ahead and plug my numbers into that. So that's 13 factorial divided by 13 minus 6 factorial. So you get 13 factorial divided by 7 factorial. Now when you do that, remember you have 13 factorial, so that'll be 13 times 12 times 11 times 10 times 8 times 9 times 8 times 7, 6, all the way down to 1. And in the denominator you have 7, 6, 5, 4, 3, 2, 1. So every number in this denominator will cancel out with starting here at the 7. So in the numerator you really will only have 13 times 12 times 11 times 10 times 9 times 8, because anything beyond that's going to cancel out with your denominator. And as you can see here, that's actually exactly what we had when we wrote it out this direction. So you end up with the same answer because it essentially is the same problem. Number 3, find the number of distinguishable permutations. Distinguishable means that they're separate from each other. Permutations are the letters of mathematics. So the first step you want to do is you want to count how many letters are in the word mathematics. So if you count them, you end up with 11 letters in the word mathematics. So in the numerator, we're going to write 11 factorial. And in the denominator, we're going to have to divide out because this one has that special case of repetition. So I'm going to look through the letters of mathematics, and anything that repeats is not distinguishable. So I have to divide out that repetition. So I see that the letter M repeats 2 times. So I'm going to divide that 11 factorial by 2 factorial because there were 2 M's. And then next up I see an A, and I see another A, so again that repeats 2 times, so I'm going to write 2 factorial again. And then I see that T has repetition, and there are 2 T's in mathematics. And there are no other repetitions in letters. So you're going to do 11 factorial, and to be honest, I think it's probably easier if you just do 2 factorial in your head before you type it in the calculator. 2 factorial just means 2 times 1, so that just gives you 2 times 2 times 2. So I would simply type in the calculator 11 factorial divided by 8, because I did 2 times 2 times 2, that's where the 8 came from. So when you do that, you end up with 4,989,600. For number 4, a shelf can hold 7 trophies. How many ways can the trophies be arranged if there are 10 trophies available? So the trophies are different. So if you had one for baseball or if you had one for football, they are in fact different trophies, so order does matter. So we have 7 trophies. So 1, 2, 3, 4, 5, 6, 7. For the first option, the first one, you have 10 trophies available. Then 9, 8, 7, 6, 5, and 4. When you type that in the calculator, you get 604,800. Or you can use the formula for permutations. You have 10 trophies to choose, so that's your N value. You have to choose 7 of them for the shelf, and then you would plug that in the formula as 10 factorial, that's the N value, and 10 minus 7 factorial. Again, you can just type this in the calculator, and then that'll give you the problem or the answer right away. Go ahead and try number 5 and 6. They're both pretty similar to what we've done before. So pause the video and come on back and see if you have the right answer. So for number 5, I did it both ways. I just did the fundamental counting principle. So you had 10 questions for the first question, 11, 10, and 9. And then I used my formula. N was how many questions we had in the pool. And we were choosing 4 of them for this test. So then I did 12 factorial divided by 12 minus 4 factorial. And again, it turns out to be the same answer of 11,880. And for number 6, find the number of ways 10 cheerleaders can make a circular formation. So that's just 10 factorial. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And you get 3,628,800.